In this video of X Minute Math, we're going to talk about how to rationalize the denominator of a fraction that looks a little bit more involved than we saw in a previous video on this topic. In particular, we're going to be looking at fractions where the numerator is something and the denominator is something else plus the square root of something else. Now I'd like to start off with a non-example. So this is not how it's going to work, but often seeing how something doesn't work can help us figure out how something does work. Okay. So now with our previous method, if I wanted to rationalize the denominator of this fraction, 3 over 1 plus root 5, if I'm not paying attention, I might think, okay, I've got a root 5 in the denominator. I'm going to use my same old trick. I'm going to multiply by root 5 over root 5. That's really just multiplying by 1. I think I'm being clever and rewriting this without changing the value. Let's see what happens. Well, I end up with 3 root 5 in the numerator. And downstairs, I'm going to have to distribute. Right? I get 1 plus root 5, the original denominator, multiply by root 5 from the other fraction. Okay. Well, in this instance, what happens is the numerator stays 3 root 5, but in the denominator, when I distribute, I'll get root 5 plus root 5 times root 5. That's just 5. And now, okay, I'm kind of stuck. Okay, I've certainly rewritten my expression. All of these equality signs are true, but unfortunately I haven't managed to rationalize the denominator. I still have this ugly irrational number hanging around. So we're going to have to try something else. So instead, we're going to use what's called the conjugate of the denominator. So we'll talk about what that is in just a second, but what I'd like to do first of all is just show you an example of it actually working in action. Okay. So let's take that same fraction we were looking at before. So 3 over 1 plus the square root of 5. Okay, and I want to rationalize that denominator, make the denominator nice and rational. I'm still going to use my trick. I'm going to multiply by something that is effectively 1, but what I'm going to do is I'm going to take that denominator and replace that positive sign with a minus sign. So I'll turn it into 1 minus root 5 and multiply by that fraction. Okay. Now this might seem a bit mysterious, but let's see what actually happens when I carry out this multiplication. Well, upstairs I'll just get 3 times the 1 minus root 5. Downstairs I get 1 plus root 5 from the original fraction, and I'm multiplying by 1 minus root 5. Okay, so I have some distributing to do here. So I'll have my first, outside, inside, last from the FOIL method. So I'll leave the numerator basically figured out. Downstairs when I distribute, I'll get 1 times 1 minus 1 times root 5 plus root 5 times 1 minus root 5 squared. Wow. Now something pretty interesting is about to happen. Notice I have plus root 5 and I'm subtracting root 5. So actually, those terms will cancel. And if I pay attention, my numerator is still 3 times 1 minus root 5. Downstairs, I've got 1 minus the surviving term. Okay, that's the square root of 5 all squared. By definition, that's just 5. So if I tidy this up, the denominator is now minus 4. Let's pull that negative out the front of my fraction. So I end up with a nice rational denominator of 4. So what is the conjugate of the denominator? Well, in general, if we have the denominator looking something like a plus the square root of b, like we had in this instance, where a and b are just variables I'm using for convenience. The conjugate of that takes that positive and makes it negative. So I get a minus the square root of b. In the instance that my denominator has a negative to begin with, so it looks something like c minus the square root of d, the conjugate of that, again, just reverses that negative sign back to a positive. So I'll get c plus the square root of d. So now that we have the vocabulary figured out, let's try one more example here. Okay, so if I want to rationalize the denominator of 6 over negative 3 minus root 10, I'm supposed to multiply by something over something that's just going to be equivalent to 1, multiplying by 1. Well, what we need to do is we find that sign in between the negative 3 and the root 10, and if it's negative, we make it positive. If it's positive, we make it negative. So here, because it's negative, I'm going to make it positive and multiply by this fraction. Now, crucially, I do want to point out that this negative in front of the 3 does not change to a positive, okay? It's still negative 3 in the conjugate. It's just that very special sign in between the negative 3 and the square root that changes, okay? So let's see what happens when we carry out this multiplication. Okay, upstairs I'll have 6 times negative 3 plus root 10, and downstairs I'll have to distribute again. So I have negative 3 minus the square root of 10 times negative 3 plus the square root of 10. If I carry out my FOIL, my distribution, first outside, inside last, I'll get that nice cancellation happening again. So my first terms, I get negative 3 times negative 3. I get negative 3 times root 10. I get positive 3 times root 10, right? That's coming from this term multiplying with this term. The negatives will cancel out to give me that positive. And then I have subtract negative 10 squared. So notice indeed the root 10 terms cancel because I have a positive version and a negative version. And what I'm left behind with is 6 times negative 3 plus root 10 all over, well, I have negative 3 all squared, that gives me 9. I'm subtracting off the square root of 10 all squared, that's just 10. So my denominator becomes negative 1. So that really just is giving me a negative sign in front there. Okay, but this is okay, this is totally acceptable. Sometimes when I'm rationalizing a denominator, the fraction actually kind of vanishes and clears away because there's just a denominator of 1 hanging out in the background. And that's it. Now, if you want one more minute of math, what I would challenge you to do is try rationalizing the denominator of this fraction here, where I'm involving a variable. See how you get on with that. Please leave a comment if you have any questions about rationalizing the denominators for these slightly trickier fractions, or if you have a request or a suggestion for what to cover in our next video. And as ever, if you want to do X minutes of math, Y more times, don't forget to subscribe.